which basically controls the timing of the input information bit. That means input information bit. So, and that basically done by the state diagram. That means we have to initiate the FSSMS. That means this machine, this finite, we have to initiate this finite state sequential machine by 0 0. Okay, so here in this example, we have taken x of -1 and x of -2 equals to 0. That means we have initiated the encoder, timing controller, which is called FSSMS, by 0 0. That means the state diagram is starting from the 0 0. Okay, so we have initiated the time domain or the timing of the encoder as 0 0. So that's why, because x of -1, so -1 and -2 is depicts the past value, so it's a 0 0. So we are starting from the 0 0. So this is the initiation process. So for the initiation process, we have just taken this x of -1 and x of -2 as 0. Okay, so that is the significance of this assumption. Okay, so here is a little bit thing. This is the last thing. Why this is called the convolutional? Okay, why this code is called the convolutional code? So you have done the convolutional or convolution operation in signal system and also DSP. So what was the formula? The formula was hk x of j minus k. So here you have to just follow. You don't have to remember this this proof, but this is for your knowledge only. Why this is called the convolutional? Okay, convolutional coding. So C0J, that means code bit stream. This is the code bit stream. As we have seen that code bit, this is the code bit stream for the 0 bit. So from the previous, we have generated this stream, this bit stream for the 0, code bit 0, and this bit stream for the code bit 1. Okay, so C01, so C0J for the j instant equals to xj plus xj minus 2. If we assume that xj, this expression is basically assumed. Okay, so C0J, that means for the j instant, the code bit 0, that means the code bit stream equals to the information bit xj at the j instant and x of j minus 2, that means j minus 2 instant, the information bit at the j minus 2 instant. So here the value of the j minus 1 we don't know, so the coefficient of xj equals to 1. So 1 dot xj plus 0 dot x of j minus 1, because this is missing, so missing term, and the coefficient of x of j minus 2 equals to 1. So 1 0 and 1, and this is equals to what? The summation k equals to 0 to 2. Okay, so C0J equals to xj plus xj minus 2, and here the term is missing, which is x of j minus 1. Okay, so that's why we're just considering the summation. So this summation is being written as k equals to 0 to 2 x0 k x of j minus k. Okay, and this is the convolutional form. Actually, these coefficients are basically represented as h0 for the 0 bit. Actually, these are called the filters. So h00, h00, that means the first coefficient is 1. The second coefficient is 0, that means this coefficient is 0, and this coefficient is 1. Okay, So for C1J, this is for the code bit 0, and this is the code bit 1. This is for the code bit 1. So code bit 1 equals to what? Xj, Xj minus 1, and Xj minus 2. Okay. So here we can get all the coefficient for this 1, for this 1, and this 1. So these are the expression of the convolutional. So here in this expression, h10 equals to h11 and h12 equals to 1. So all the filters, these are basically the filters. So filters for the code string. So these are basically the filters for the code string. So these are basically one. So code is generated by convolution of input information bit sequence. So that's why this is called the convolutional code, because this code bit is basically generated by the information bit. So let me draw this code bit for the 0. Okay, this code bit for the 0 is generated by the addition, binary addition or XOR addition of information bit of the present instant j, and also information bit for the j minus 2 instant. Okay, so and let me just read as it. So the code is generated by the convolution of the input information bit sequence. So these are the input information bit sequence, and these are the coded bit sequence, as we have seen from the previous example. Okay, so these basically the information, the information bit sequence, and these are basically the coded information bit sequence, the coded bit sequence, actually the code bit stream, and these are the information bit stream. And if we represent like this, okay, this form, a convolutional form, okay, so we can relate it to the convolutional structure. This is the convolutional function. So that's why this is the convolution. So that's why we can say that the code is generated by the convolution of the input information bit sequence. So that's why this is called the convolutional code, right? So up to this lecture was up to this, and this is the initiation. This is basically the basic of the convolutional code, introduction to the convolutional code, you can say, and why this is called the convolution. So we have covered the why this is called convolution, convolutional code, and the example of the convolutional code output, how to generate the output bit, that is output code bit, from a given information bit sequence. This information bit sequence will be given to you, and from that you have to generate the code bit, right? And also you will be asked to calculate the rate, that means the code rate. And as you know that for the convolutional code, always the rate will be half, and this is the formula, that means the number of the information bit by the number of the code bit. So you have to always remember that for each bit sequence, for each information bit sequence, there will be 2 code bit. That means for the code bit 0 and code bit 1. So these are basically the bit stream. Okay. So information bit stream. So one information bit stream is given, and then you have to generate this 2 code bit stream. This is basically not needed for your examination. It's for your knowledge only. And okay, we will discuss this structure later and this derivations later also. The delay domains, actually this is the D domain or delay domain. How it works, so we will discuss later. This is the encoder conception, and this is very important. The how you define the convolutional code, that means cconv equals to n, k, and capital K. Okay, where capital K is a memory segment, or delay segment, how much delay you are using. Actually, if you see this picture, here, uh, two delays are being used. Okay, D and D. So these two delays or these two memory segments are being used. So these two memory segments are called, is basically defined as capital K. So K equals to, for this system, the capital K, the value of the capital K will be 2. Okay. So this is NK and capital K, and K is the message bit representation. N is the total code bit representation. Okay. And this is the FSSMs. That means the finite state sequential machines, which is basically used in the encoder for controlling the timing, diagram of the input bit sequence. Okay. This is the basic significance of the FSSM. Actually, finite state sequential machine, it basically do one thing: to control the timing diagram, the timing instant of the input information bits. That's all. Now here is a concept, some conceptual thing, that this is the capital K, this is the memory section, and we are this is very important, this is very much important. You have to remember, this is a property, these are the property that the encoder segment, of the n bit not only depends on the present input sequence of the K element of the encoder, but also they depends on the previous segment of the K elements. So that's why we are just considering I minus 1, I minus 2, I minus k. And this I minus k or I minus 2 or I minus 1 is defined as j. That means j minus 2 in that sequences. Okay. For the C0, we have considered xj and xj minus 2. So that j minus 2 is basically I minus 2, and these are the concept. So we are considering the previous inputs, previous information bit sequence, and this is the encoder concept. Encoder, how we are feeding encoder with the message information bits, which each segment consists k number of bits, and we are generating encoded, mind it, encoded bit. So for the convolutional code, we feeding the encoder with the message information bit, but we get the output of encoder as the encoded bit sequence. Okay, which each segment consists n number of bits, and as you know that n is always greater than k. And this was the initial thing. Okay, so up to this, please take this note, and if you have any queries, if you have any doubt by understanding it, then please feel free to ask. Okay, don't hesitate, uh, because this is the first attempt to do the lecture like this. Okay, so thank you.